Hello my dear students, this is Akash SD and welcome to the SD Physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the question from the moving charges and magnetism and matter combined. This question belongs to the combined chapter from the 12th. Okay, so let's go through the question. So here you can see the question is: a solenoid of 1200 turns is wound uniformly in a single layer on a glass tube. Remember that, glass tube, 2 meter long and 0.2 meter in a diameter. The magnetic intensity at the center of the solenoid when a current of 2 ampere passes through it, how much? Okay, so first let's note down the data. So data how much is given here? See, the total number of turns, it is given here 1200. Okay, and after that you can see very well the length, it is given here how much here? 2 meter. Okay, and if you talk about here the diameter how much has given here? 0.2 meter. So here the question arises, can this solenoid be considered as a infinite length solenoid? The condition is that the length should be very large compared to the radius or diameter. So you can see very well, if in case you take here the ratio, let's take for example this L by R. So this L by R will come how much here? 2 by nearly 0.2, and it will come here 10 times nearly. Now you can see very well. That means I can write here this length is the nearly 10 R, or we can tell, okay, L is the greater than R. Okay, 10 times, it's a very big value. Okay, so here in this situation we can apply the infinite length of the solenoid formula. Okay, and one more thing, current how much is given here? The current, it is given here, students, 2 ampere. Okay, so now we are going to use here the formula. See here, we know that magnetic field of the solenoid B equal to how much here, students? Remember that here, B equal to mu naught Ni. For which situation? If in case air core solenoid is there, but here what is this? This glass tube is there, and this glass tube is having some permeability. Okay, so instead of mu naught we will just use here water. Instead of mu naught we will use here just mu. Okay, because glass is there, air is not there. Okay, and remember that here this B equal to mu naught Ni will be equal to how much here? From the magnetism and matter chapter, this one we can write here mu h also. Okay, this is for the solenoid formula and this is for the general formula for the material and all. Okay, so students, when you will compare both the things, what will happen that here both the sides, this mu and mu will cancel out. Okay, so hence what we can write here, this H is given here N into I. What is this? H equal to N into I, that is called the magnetic intensity. Okay, and it only depends upon the current independent of the material of the solenoid in which the wires of the solenoid is wound. Okay, the wires is wound. So in this situation what we can write here, students, say this H equal to given by N. What is N? N is the number of turns per unit length. Okay, so we can write here, see, N by L into I. Okay, so N how much is given here? See very well, 1200. Okay, length how much is given here? 2 meter. Remember that here. And current I how much is given here? You can see very well, that is also how much here? 2 ampere. So here what will happen that here, this 2 and 2 will cancel out, it will come here 1200. How much it will come here? It will come here 1200, and you can tell here I is the ampere, N is the turns, actually the number of turns per unit length. N is the what? Number of turns per unit length. That means here unit is going to be ampere per meter. Is it? So which option is matching is there? 1200. So you can see very well, when you will see from the scientific point of view, you can see very well the correct option is here option B. Kindly see very well, students. So here as they have calculated magnetic intensity, so magnetic intensity will be how much? H equal to Ni. Whether this is the glass tube or some other material is there, magnetic intensity is the independent of the material and all that. So students, I hope so you have understood this video very well. Keep studying, keep growing.